Hello friends, in this video I'd like to solve the following problem from the Singapore Mathematical Competition 1988, problem number B3. We wish to find all the positive integers n such that 1 plus 2 to the power of n plus 3 to the power of n plus 4 to the power of n is divisible by 5. So this problem is really easy. My hint: use Fermat's little theorem, which says that if a is an integer, if p is a prime, which does not divide a, and if k is any natural number, then the following congruence is true. A to the power of k is congruent to a to the power k modulo p minus 1, modulo p. So we can reduce our problem only to a few possible exponents. So give this problem a try and I will see you in a minute. Okay, so let's notice that here we can use Fermat's theorem. So let's write it by Fermat's little theorem. We have the following: 1 to the power of a is congruent, not very interesting, but 1 to the power of n is congruent to 1 to the power n modulo 4, modulo 5. 2 to the power of n, 2 is co-prime to 5, so it's so this is congruent to 2 to the power n mod 4, modulo 5. And similarly with 3 and 4. And that means, and let's also notice that n modulo 4 is either 0, 1, 2, or 3. Which means that our problem is now reduced only to verifying 4 numbers, namely n 0, 1, 2, and 3. So let's do it. If n is congruent to 0, modulo, or maybe let's write it, if n equals 0, what happens then? 1 to the power of a, 2 to the power of a, n, 3 to the power of n, 4 to the power of n, it's just 4, and it is not congruent to 0 modulo 5. If n equals 1, we have the following: 1 to the power of n, 2 to the power of n, 3 to the power of n, 4 to the power of n. It's just 1 plus 2 plus 3 plus 4, and that's 10, and 10 is congruent to 0 modulo 5. Okay, if n equals 2, then 1 to the power of n, 2 to the power of n, 3 to the power of n, 4 to the power of n, it's just, sorry, to the power, yes. So we have 1 squared plus 4, it's 5, 5 plus 9, it's 14, 14 plus 16 is 30. Again, this is congruent to 0 modulo 5. And lastly, if n equals 3, 1 to the power of n, 2 to the power of n, 3 to the power of n, 4 to the power of n. Complicated calculations, but it will be 1 plus 8 plus 27 plus 64, I believe. And that will be 72 plus 28. 72 plus 28 is 100. It's 100. And that is again congruent to 0 modulo 5. And that means that we have our answer, namely, our answer goes like that: 5 divides 1 plus 2 to the power of n plus 3 to the power of n plus 4 to the power of n. if and only if 4 does not divide n. Why is that? Because only in the congruence to 0 modulo 4 we had lack of congruence modulo 5. In every other case, the congruence was true. And that is our answer. Okay, very well. So thank you for watching and I will see you next time. Goodbye.